Hello, everyone. So we have a great question about logarithm. That was, I guess, number 6 on the test. So we are looking for the solution for this system, and then we are given two pair of solution, and we like to multiply the coordinates and as our argument of the logarithm base 30. Okay, so it's kind of complicated, but let's actually look at what we are given so carefully so we can maybe get something out of it. We have the base 225 and argument is x. In the next equation, the base is x, the argument is 225. So which is something we should think about it. And the same thing happening right here as well. So that's why I like to remind something, one of the properties of the logarithm. So let's say you have I don't know, like x and y. If the base and the argument is actually swap, that is gonna be reciprocal of your the logarithm. So which can be written as 1 over log base with y of x. Okay. And if you are not sure about this identity, so you probably need to review that as well. But sometimes we can just multiply these two and then make it equal to 1. So that is also useful. So the base x of y times the logarithm base with y of x. When you multiply, the product is 1. So these two are the same thing. You're just rewriting this equation instead of fraction. So why this is important? Because since we are given two different logarithm with this similar relation, maybe we should keep this in mind to use it, right? So to do so, I'm going to do some sort of substitution, right? So the first substitution is this logarithm base with 225 of x. I'm going to call this is equal to a, and then the other one, I'm going to call that b. Okay, so the logarithm base 64 of y is equal to b. Okay, so let's think about this. And the first equation now is going to be a plus b equals 4. And the second equation, again, this is just the reciprocal of this one. So you can just say, if this guy is equal to 8, then means this has to be 1 over a. So that should be 1 over a minus 1 over b. And then this is equal to 1. So, it's much better than these equations. So we can solve this equation either like using substitution or eliminating one of those variables, but I think substitution is good. So if I take the a's alone, right, so that should be 4 minus b. And then I can plug this into the second equation. So that will give us 1 over a, which is 4 minus b, and minus 1 over b equals 1. Again, I can find the common denominator at this point, so I may multiply this by b, so that will be b over 4 minus b times b, and then this is multiplied by 4 minus b, so you should get 4 minus b over b times 4 minus b, and this is equal to 1. So if I simplify this a bit, so the numerator would be just b minus 4 plus b equals 4b minus b squared. And if you pull everything one side, so add b squared to both sides, so you will get b squared, and subtract 4b from both sides, so you have 2b already, minus 4b will be minus 2b, and then there is a minus 4 equals 0. Okay, so at this point, you may either use a quadratic formula or completeness square, so I'm going to go with completeness square. Okay, so that will give us b squared minus 2b plus 1, and this is equal to 5. So if you are not sure what I did right here, so just complete square basically. And this is b minus 1 square equals 5. So b has to be plus or minus root 5 plus 1. Okay, so this is my b value. So if I plug into this equation, I can get the a values as well. So from there, so you will get, if b is like root 5 plus 1, so you should get 4 minus plus or minus root 5 plus 1. So from there, so I will get a. If this is root 5, so you will get like minus root 5. So 4 minus 1 will be 3. So 3 plus root 5 or minus root 5. Okay, so we have two solutions for A. We have two solutions for B. So which is expected because we are told those are the coordinates x1, y1, and x2 and y2. So those are basically our A and B's. And now we want to multiply those values, but this is logarithm with base 30, right? So we should handle those first. So, and then I just got the x1 and x2 and stuff like that, but I do need to know their values. I mean, I didn't actually get the x1, x2s. I got the A and B's, okay? So if I plug into this equation, so you do see this, like, let me write different color. So the log 225 and x1, x2, right? So if I take this one, so let me write this argument in parentheses. If this is equal to, like, you know, the when you have the argument as a product, so you can just write as a sum of two logarithms. So this could be written as log 225 x1 plus the log 225 x2. So why this is what I'm trying to do now, because I do know the x1 and A and B's, so I do know their result, right? And this guy is equal to A, so I do have two different A's based on those. So that means this is one of the A's, this is the other A. So if you add the A's, so like 3 plus root 5 and 3 minus root 5, so this is equal to 6. And if you do the same thing with the next one, so you will have the log 6, the base 64 of like y, I will just write y1 and y2. And the same reasoning, so you get log like with base 64 of y1 plus the log base 64 y2. And the result for B was this logarithm. So this is 1 minus root 5 and 1 plus root 5. If you add them, you get 2. So that is going to be the answer. Okay, so we do have those, but what does this look like? This is equal to what? This is equal to this guy, right? So that means if you just rewrite this in exponential form, so the log with base 225 of the product is equal to 6, right? So that means if you take this 225 to the 6th power, so you will get the product of those two x1 and x2s. And the same thing with the second function. So let's actually do that a bit clean area. So let me clear this piece. So I'm going to leave that for now. Okay, so then our next step should be, I guess, a bit clear at this point. And, you know, we do have, the question was asking the log like with base 30. So let's write that. Of the product of those x1, y1, x2, y2. And I do know from this guy, x1 times x2 equals 225 to the 6th power. From this guy, the y1 and y2 equals 64 to the 2nd power. Again, if you are not convinced with these, please pause a moment and look at what we did before you move on. And we are told now this is 225 to the 6th power times 64 to the 2nd power. And we just like to write this number as power of 30, right? So that's kind of what we want to do to get what we want. And you can just try, like, this is like 15 squared. So, and then this is like 2 to the 6th power. So maybe we can use that information to get our like 30 as base. So that's 15 squared. And then square to the 6th power will be 12th power. And then this is 2 to the 6th power. To the 2nd power will be 2 to the 12th power. And then this is our argument. And you know, this is like the same exponent, so you may multiply 12 and like 15 and 2, which is 30. So you will get the log with base 30, and then argument will be 30 to the 12th power. So you can take this as number in front, or what power of 30 is equal to 30 to the 12th power. So you can say this is equal to just 12, which is our definition of the logarithm, if you remember. Okay, so then the answer to this question is just 12. So I hope that makes sense, and I'll see you in the next video.